Hello students, in this session we will do the chapter of motion in a plane, okay? So in the last sessions we completed motion in a straight line. So it actually means a one-dimensional motion, we saw that one, right? So the topics that we covered in the last sessions were like displacement, velocity, acceleration, right? So we saw the intuition behind it. Same way we completed all those graphs that are related to these three parameters, fine? And then we completed kinematic equation. Same way we also completed relative velocity, right? So we saw the foundation of relative velocity. Main thing comes into relative velocity when you have vectors into it, okay? So we'll see vectors in this chapter, which means in motion in a plane, okay? So that is something that we will discuss in this session itself, fine? So in this session we will see vectors and the logic behind those vectors, fine? So then we will see like trigonometric functions. So trigonometric functions are like sine theta, cosine theta, tangent theta, right? You might have already known those things, sine, cosine and tangent thetas. Anyway, I'll give you the basic understanding, right? Many students might have known, that's not the thing. But the thing is, from this trigonometric function, we will be building up all those upcoming chapters. So you should be clear with the logic that I'm about to give you, okay? So that is something that we will see. Then we will see like parallelogram law, right? So with that parallelogram law, we'll complete this session, fine? So we'll see like 3 topics in this session, fine? So with that, we'll conclude this session. So in the next session, we will see like motion of a projectile, okay? So we'll see like projectile motion on a horizontal surface and then on the oblique surface, okay? So that will be the next session topic. And then in the last session we'll do like uniform circular motion, fine? So with 3 sessions I'll complete all those topics, right? So these are the things that we will see. So let's jump into it. First, let's see what is meant by vectors, fine? So vectors comes into picture because of the graph, okay? So first you should be clear with marking the points in the graph, right? So these are like easy things, right? We have already learned, you should have already learned in your math classes. So you have got like graph, which means along the x-axis we'll put right side to be like positive and the same way left side will be like negative. On the y-axis you'll have like top side to be like positive and the bottom will be like negative, right? So this is how we'll draw the graph. This is how we'll just put numbers to the graph, right? So you should know this one. As I have told you, in the motion in a straight line, we got the object to be moving to and fro, front and back, something like that, which means that's one dimension. But in this situation, you will be able to move along the x-axis. The horizontal line will be like x-axis. Same way, you will also be able to move along the y-axis, okay? So those two things are possible, fine? In this graph, I'll consider the first point to be like 2, 3, okay? So A is actually 2, which means you have 2 units along the x-axis and then 3 units along the y-axis. That's how I have taken it. So A 2, 3. I have taken the first point and then let me consider the second point, which is like 2, 1, right? So 2 units along the x and then 1 unit along the y. So that's how I have taken this one. Now I'm going to make vector out of these 2 points, okay? So whenever I consider a vector, it actually means you have final point, which is the point that is here, and then the starting point will always be the origin, which means that's going to be like 0, 0. That's how I'll consider it, right? Fine. So whenever they give you some vectors, you just have to pick the x, y, and then z component, okay? So in this situation, it is like 2-dimensional. Therefore, you will have only x and y component. If it was like 3-dimensional, then you will have z components into it. So here they have given you just 2 components, which means like x and y, right? So to make an vector out of it, the final point will be like 2, 3, and always the initial point is going to be 0, 0, right? So if I have to make a vector for this first point, which is like 2, 3, this will be my final position and the initial position will be like 0, 0, right? As I've told you. Then to get a vector out of it, we'll have to always start from the origin and then you'll have to draw a line, okay? So the ending point of that will be like 2, 3, and then arrow mark should be put such that it is facing the final point. So the final point is like 2, 3. So you'll get a line something like this, right? So you will have a line like this. Okay, so this will be my vector A. So now I have got my vector A, right? So you should know how to create a vector by using the points. It's just simple. Always connect that final point with the origin, okay? Just draw a straight line, that will be my vector, right? So now I have got the vector A. Then I'll have to put the vector B. So vector B is like 2, 1, right? This will be my vector B, which is like 2, 1. So now I have got both vector A and then the vector B. Next, what I'm about to do here is to do the addition. Okay, so before doing the addition, now I'll introduce the concept of unit vectors. Okay, so unit vectors actually means when you measure its length. Okay, take a scale and measure its length, the length will be equal to 1. Okay, it could be like 1 meter, 1 centimeter, depending on the convention that you are about to choose, but the thing is it will be equal to unity. That is why it is called as unit vectors. Okay, so in this case I'll fix certain unit vectors as standard things. Okay, if you are going to move along the x-axis, for each one units covered, I'll consider it to be like I cap. Okay, so that's the convention that I'm going to stick to. Therefore, along the x, you will have the first component to be like x I cap. Okay, that is chosen. Then you have along the y, right? So in y, unit vectors are considered as j cap. Okay, then along the x you will have, then along the z, okay, z component you will have like k cap. Fine, so these three are the unit vectors that you need to know: I cap, j cap, and then the k cap. Okay, so these are unit vectors because along that particular axis, one I cap equals to one unit covered. Okay, two I cap equals to two unit vectors covered. That's how I'll have to consider. Okay, so here if I consider for the vector a, you will have 2 I cap, and then you'll have like plus 3 j cap, because all those movement is along the positive axis. Therefore you will have like 2 I cap, because in the x axis you got like 2 units moved, and then same way in the y axis you got like 3 units moved. Therefore you will have 2 I cap plus 3 j cap. Okay, so the first vector is like 2 I cap plus 3 j cap. Now I have got the vector for the point 2 comma 3, right? So that thing is done. Then I'll get the vector for the point B, which is like 2 comma 1. That's obviously going to be 2 I cap plus 1 j cap, or else I'll be able to put j cap, right? So in this situation, as it is like two-dimensional motion, you do not have z vector coming into picture. Okay, z component coming into picture, which is like k cap. Okay, so it should be like 0 k cap and then 0 k cap. Fine, so everything vector that applies to two-dimensional will also apply for the three-dimensional stuff. Okay, so if you are clear with the 2D motion, then three-dimensional motion is obviously easy, right? So just put extra one component into it, then the math is just the same thing. Do the same math, you'll get the answer. Fine, got it? So now I have got vector A and then the vector B, right? Next, what I'm about to do is I'm just going to add those two components. Okay, so now I'm going to add vector A and then the vector B. So to get the vector addition, how I should consider is, let's consider the first case. There is a guy who is standing on the origin, and then he is moving along vector A, which means he comes to the final point, which will be like 2 units along the x and then 3 units along the y. So that's how we'll have to consider it, right? So that will be my final point. Next, what is going to do is he is going to move a displacement of vector B, which means he is going to move 2 units along the x, extra 2 units along the x, and then 1 unit along the y. So that's what it is going to happen here. So if that's the case, what I do is I take this vector and then put the tail of this vector on the head of this vector. Okay, so if I put it in such fashion, then I'll get the final position. So obviously the final position will be like 2 units along the x because of this vector A, same way 2 units along the x because of this vector B, right? So that's going to be like 4 I cap, right? Or else I'll be able to add it, which will be like 2 I cap plus 2 I cap, that will give me 4 I cap along the x, same way 4 j cap along the y, right? Plus 4 j cap along the y, which means 3 units along the x, y because of vector A, and then 1 unit along the y because of vector B. Okay, so that will give me 4 I cap plus 4 j cap. Either you do the addition straight away, or I'll be able to do it pictorially. We will see how does it work pictorially. What I'll have to do is, as I've already told you, take the second component. Okay, in this situation I'll consider the first component to be like vector A, and then the second component here is vector B, right? So place the tail of this vector B on the head of the vector A, you get the resultant component. Okay, so if I do it in such fashion, you will have the vector B tail to be on the vector A, and then it covers 2 units, extra 2 units along the x, and then 1 unit along the y. So that will look something like this, right? So this will be my vector B. Okay, so the resultant component, so the resultant answer will be like 4 comma 4, which means 4 I cap plus 4 j cap, right? So to get the resultant vector, let me draw a line. Okay, as usual I'll have to draw it from the origin, so that will be my resultant vector, which is like vector R. Okay. So this is how you do the vector addition, or else I'll be able to do it other way around. Here, let me put the tail of vector A on the head of vector B. That will also give me the same resultant vector. Okay, so let us do it. So you have like 2 units along the X because of B component B, and then you will have one more 2 units along the X because of the component A. Okay, so that will be this distance, and then because of component A, you get the 3 units, right? So if you just move it parallelly, you will have the vector A on the head of vector B. So that will be like, so this will be my resultant vector, right? So this will look like a parallelogram, right? So that is why we will do the parallelogram law in the final part of this session. So this is like vector A. Okay. In this situation, it doesn't depend on the vector that you are going to choose. Choose any one vector and then put the tail of that vector on the head of the other vector. You will end up getting the resultant vector. Okay. So that is what has happened here, right? So this will give me like vector addition, which is nothing but vector A plus vector B, right? So next what I'll do is I'll do the vector subtraction, which means vector A minus vector B. Okay. So here first let me do it mathematically, then I'll get you the graphical understanding of it. Okay, so if I do the mathematical subtraction, it's like vector A minus vector B, right? So 2 minus 2, that's going to be like 0 I cap. So that's going to be like 0 I cap, and then you have 3 minus 1, which will be like plus 2 j cap. Therefore, if I do the vector subtraction for like vector A minus vector B, I'll get the resultant vector to be like 2 j cap, right? Let us see it graphically. So in this situation, vector A is done. So the vector A is already drawn in a correct direction. So the next thing is vector B, I'll have to flip the direction, right? So because it is like negative vector B, which means it should be like minus 2 I cap, and then it should be like minus j cap, which means the point will be like minus 2 comma minus 1. So that will be my point, right? So to plot it other way around, let me do it. So this is like vector B. I'll have to draw it other way around, which means minus 2 I cap and then minus 1. I mean minus 2 I cap minus j cap, right? Or else minus 2 comma minus 1 will be my negative vector B, right? So to get that one, so that will look something like this. So this will be my negative vector B, right? So this is like, now I have got the negative vector B, then I can do the vector addition straight away, right? Because A minus B or else A plus minus B, both those things will give you the same thing, right? So now I have found the negative vector B, then I'll do the vector addition, same thing, and then I'll get the subtraction of those two vectors, okay, fine. So to get the resultant vector, what I'll have to do is I'll have to put the head of one vector, I mean the tail of one vector on the head of the other vector. The first case I'll choose minus b. Okay, so if I choose like minus b to put it on the head of the vector a, then you will get something like this, fine. So this will be my negative b vector. Okay, obviously the final answer will be like 2j cap. That's what I've got here, right? That is like 2j cap, right? So even if you put it other way around, you'll have to get the same answer, right? So next what I do is I'll put vector a on the head of minus b. Okay, so if I put it that direction, I'll still end up getting minus 2j cap. So this is how we'll have to do it pictorially. If it is like mathematical just numbers, then do the addition subtraction straight away, you'll get the final answer, fine. So now you should have gained the basics and the intuition behind vectors, right? So vector is something that I built up from the points, okay, in the graph. Then what I did is I just joined it with respect to the origin, then I did the vector addition and then the vector subtraction. Okay, so these are something that you need to know, fine. So you should know what is meant by unit vectors. Unit vectors actually means it is just 1 unit distance covered in those respective axes, fine. So you will have like unit vectors to be I cap, j cap, and then the k cap, fine. So if it was some other direction, okay, arbitrarily I could choose like 30 degree from the x, and then I'll have to get a unit vector along it. How should I do it? Okay, so that's what we will see next. As if now what you need to know is along those three axes I'm going to give a particular alphabet name to it. Okay, so alphabets to it, which is like I cap, j cap, and then the k cap, right? From those three alphabet I'll be able to calculate rest all other unit vectors along any random direction that could be easily found. We'll see that one, fine. So the statement that I've written over here is, for vector addition, place the tail of one vector on the head of the other vector. Okay, so that is how you generally do vector addition. If you have to do it in a graphical way, okay, in a mathematical way, that is easy. Using numbers, that is easy. Do the subtraction or addition straight away, you'll get the answer, right? So these are the things that you need to know regarding the vector basics. Then we will see what is meant by unit vectors. Next, I'll choose vector in some random direction, fine, and then I'll find unit vector for that randomly chosen vector, okay? So here the vector that I chose is like 4 I cap and then 3 j cap, which means you'll have like 4 units along the x-axis. Same way you got like 3 units along the y-axis, right? So for this direction, I'll have to find unit vector, which means the length of that vector should be equal to 1, okay? Or else the magnitude of that vector is going to be like 1, right? So to get the length of this vector, what I need to do is I'll have to take a scale and then measure the length, okay? The answer will be the magnitude of this particular vector, right? So magnitude actually means only the length. You shouldn't consider the signs, okay? Negative and positive sign shouldn't be considered, right? We have already known that one. To get the magnitude, I'll use the symbol called modulus, right? So here to get the length of this one, what I could do is I'll have to use the Pythagoras theorem, right? So here it is pretty clear. Along the x-axis, you got like 4 units, and then along the y-axis, you got like 3 units. This is obviously a right angle triangle. So these two are sides and this is my hypotenuse, right? So to get the length of the hypotenuse, what I should do is I'll have to do the side square plus side square, right? So to get the length of this particular vector, which is nothing but the modulus of vector r, will be equal to the root of side square plus side square because of the Pythagoras theorem, right? So side square, the first case will be like 4 square and in the second case will be like 3 square, right? So 4 square plus 3 square will be like 16 square plus 9, I mean like 16 plus 9, root of 16 plus 9, which will be like root 25, okay? So the root 25 is like 5 units, right? So obviously this is not a unit vector in this direction because the magnitude of this vector will be equal to 5 units, right? So here I have got a vector whose unit is going to be like 5 units. What I need to find here is the unit vector on this particular direction, which means the length of that particular vector will be like 1 meter. So that's how I need to find, okay? So by intuition it is clear. Vector actually means it is a combination of both length and then the direction, right? So magnitude and direction together it forms a vector. Only the magnitude is this like 5, okay? So to get the unit vector, what I should do is I'll have to divide by its magnitude. I'll have to divide the vector by its magnitude, right? 5 divided by 5 will give me 1, right? So this vector has both magnitude and direction into it. So if I divide it by its magnitude, which means 5 in this situation, I'll get the unit vector, right? So let us find that one. So you'll have vector r divided by modulus of vector r. So that's the logic, right? So vector actually has both into it, magnitude and then the direction. Only to get the direction and to make the magnitude 1, I'll divide it by its magnitude itself, okay? So if it was like 5 I cap, the magnitude will be like 5 units, right? So that will be like 5 I cap. If I divide it by 5, I'll get I cap, which is nothing but the unit vector on that particular x-axis, right? So same thing, same logic here. So obviously that should work for the combination of all those unit vectors, right? So here you have vector r divided by modulus of vector r, which will give me 4 I cap, which will give me like 4 I cap plus 3 j cap divided by 5. Okay, so if I split it, you'll have 4 by 5, yeah, you will have 4 by 5 I cap plus 3 by 5 j cap, right? So the unit vector will be like 4 by 5 I cap plus 3 by 5 j cap. So that's going to be the unit vector of a vector in this particular direction, okay? So you should be clear with this unit vector concept. So if I need to get a unit vector, what I should do is I'll have to divide the vector by the modulus of vector to get the unit vector, okay? So let's do the verification. This magnitude is actually equal to 1 or not, okay? So I'll do the verification to it. So if I need to verify it, I'll just have to find the modulus for that particular unit vector, right? So the unit vector that I've got over there was n cap, which was equal to 4 by 5 I cap, and then you got like 3 by 5 j cap, right? So if I need to find the modulus for this particular vector, I'll get something like this. Modulus of n cap, which is nothing but root of 4 by 5 the whole square, right? So same thing, Pythagoras theorem, and then you'll have like 3 by 5 the whole square, okay? So if I just square it, I'll have like 16 divided by 25. You'll get something like this, root of 16 divided by 25 plus again you'll have 9 divided by 25, okay? So if I do the math, you'll have 16 plus 9, which is 25 divided by 25. That will be equal to 1. So obviously, the magnitude of this particular vector is equal to 1. Then this is the unit vector along that particular direction, which is like n cap, right? So whenever they are asking you to find the unit vector, what you should do is you'll have to divide a vector by its magnitude, which will give you the unit vector, right? So these are things that you need to know related to vectors, fine. So this foundation and basic is enough to build the rest all other concepts, okay? So now we are going to see those trigonometric functions that I've told you, sine theta, cosine theta, tangent theta, and the logic behind it, okay? So next we will see those trigonometric functions. The idea behind trigonometric functions comes from angle and then the circles, okay? So here we considered like two circles, one is like a smaller circle and the other one is like a bigger circle, okay? So with respect to both those circles, you have an angle swept which is like theta, okay? So related to theta, you should be clear with the concept of radian and degree, okay? We have seen that concept exhaustively in the first chapter, which is like units and measurements chapter, okay? So with respect to both those circles, the angle swept theta was like same, okay? So what I'm about to consider is I'm just going to plot a point with respect to the first inner circle, okay? So if I need to plot a point on the circumference of a circle, I'll have to consider distance x in the x-axis, same way distance y along the y-axis to get that particular point for this respective theta, okay? Same way with respect to the bigger circle, how I'll get that particular point. So to get that particular point, same way I should know what is the distance covered in the x and then what is the distance covered in the y, okay, in order to get that particular point, right? So this is how you'll get that point on the circumference of the circle for that particular theta, right? So with respect to both those circles, you got the same theta, fine. So if I look at that picture carefully, you have two right angle triangles into it, right? So you got like right angle triangles and then both those triangles have like same theta, which means the ratio should also be matching, right? For example, if you have some x units moved along the x-axis in the first circle, then for the second circle, which is for a bigger circle, you have proportionate amount of increase along the x, okay, with respect to the y, fine. So the ratio should actually match, right? So it seems pretty clear that the ratios of the sides should match. So I'll use that logic to get the sine theta cosine theta out of it, okay? So let me do a trial and error thing, which means I'm going to consider the first small circle and then I'll consider big circle and then I'll make same angle theta swept with respect to both those circles, okay? From that, if I'm about to take those sides and take ratios out of it, in that situation, I get the ratios to be like same, okay? This is a kind of same notion that we have seen in the theta logic, okay, with respect to the radians. I took the curvy distance and then I divided it with by the radius, okay, and then I got the theta out of it. In this situation, I'm just going to make a right angle triangle out of it and then I'm going to divide the sides or the sides with the hypotenuse and let me see how does it relate, okay? So with that relation, I'll be able to get sine, cosine, and then the tangent theta. Fine. So here, if I do this experiment and then I'll match it, it doesn't depend on the size of the circle. Whether you take a bigger circle or a smaller circle, those sides actually proportionately increases. Okay. Therefore, the ratios you'll end up getting the same ratios. Okay. Fine. So here, in with respect to the first triangle, I have built a right angle triangle. I have taken that right angle triangle and then I have drawn it here, okay? And then the theta swept and the angle swept here was like theta and then you got like 90-degree as it is a right angle triangle, okay? So here in this situation, we know this side is like hypotenuse side, okay? Fine. Same way, the side which is close to this theta, which means which is like adjacent to this theta is obviously an adjacent side, okay? So this side is like adjacent. Fine. So the side that is opposite to that of the theta that I considered, okay? I could consider this to be my theta or this to be my theta. Fine. In this situation, I have taken the bottom point to be my theta. Therefore, this side is adjacent and the side that is opposite to this theta is obviously an opposite side. Fine. Opposite, okay? If I had considered it other way around, which means this to be my theta, then this will be my adjacent side and this will be my opposite side, right? You might have already known this one, okay? So now what I'm about to do is I'm going to get sine theta, cosine theta and tangent theta from it. So to get sine theta, what I do is I'll just consider opposite divided by hypotenuse. Okay, so these are like consideration for the sine theta. Fine. So it doesn't depend on the size of the circle that you are about to take. It doesn't matter whether you consider a smaller one or a bigger circle. Okay, which means a smaller right angle triangle or a bigger right angle triangle, it doesn't matter, but it should be a right angle triangle. That's important thing. And then you take the ratios out of it. So when you take the ratios out of those same sides, you'll end up getting the same answer. Okay, so those same answers I'll consider as sine theta, cosine theta and tangent theta respective to the sides that I'm about to choose. Okay, so here for the sine theta, what I did is I just chose opposite side divided by the hypotenuse side. Okay, so you got sine theta, which is equal to opposite divided by hypotenuse. Okay, first one is done. Then for cosine theta, I'll consider adjacent side divided by the hypotenuse side. Okay, so for cosine theta, you'll have adjacent side divided by hypotenuse side. Fine. Then for tangent theta, you'll have like opposite divided by adjacent. Okay, so you'll get something like this: opposite divided by adjacent. Okay, so for opposite divided by adjacent, what I could do is I'll be able to write this one as opposite by hypotenuse, right? So you should know this one. I'll be able to write this one as opposite by hypotenuse and then divided by opposite divided by hypotenuse. So those hypotenuse might get cancelled and then you'll end up getting opposite by adjacent. Okay, so opposite by hypotenuse is nothing but the sine theta. Same way, adjacent by hypotenuse is nothing but the cosine theta. So I'll be able to write this one as sine theta divided by cosine theta. Okay, so that will be my tangent theta. Fine. So these are the three trigonometric functions that you need to know. You might have already learned this one in mathematics. Okay, so the reciprocal of these things will be like, the reciprocal of sine will be like cosecant, and then for cosine that's going to be like secant, and then for tangent theta you'll get like cotangent theta, which is like cot theta. Okay, anyway, you should be clear with these three trigonometric functions. Okay, which is like sine theta, cosine theta and then the tangent theta. Fine. So now what I'm about to do is, using this sine, cosine and tangent theta, what I need to get is I need to get vectorial representation for this vector r. Okay, for this resultant vector, which will be nothing but radius in this situation. Okay, so here for sine theta, what I'm going to substitute is I will substitute like opposite divided by hypotenuse, right? So opposite side will be like y and then the hypotenuse side will be like the r, right? That r will be the radius in the situation. Therefore, for sine theta, I'll be able to substitute opposite divided by hypotenuse, which is like y divided by r. Fine. So instead of y, I'll be able to replace this one as y equals r sine theta. Okay, I just did the rearrangement stuff. Okay, then for cosine theta, that will be like adjacent divided by hypotenuse. So you will have like x divided by r. Fine. So for x, I'll substitute x, which is equal to r cosine theta, right? Now I have found out the x displacement and then the y displacement. Okay, so the units that is covered along the x is known, and the same way the distance covered along the y is known, right? So that particular point is known. So in order to get the vector for that particular point, what I will do, I'll put I cap for the x component and then j cap for the y component, right? So if I put, I'll get something like this: vector r, which is equal to, for x component, you have r cosine theta I cap plus r sine theta j cap, right? So now I have got vector r. Okay, in terms of vector, I have got it, which is nothing but r cosine theta I cap and then r sine theta j cap, right? So this is actually the equation for a circle, right? So this will be my radius, and then for whatever theta that I substitute, I'll get the respective points, right? So if I substitute for 30°, then I'll get the respective point on that particular circle for 30°, right? If I substitute like 60, 120°, whatever degree that I substitute in, I'll get the respective point on that particular circle, right? So I'll be able to call this vector representation as the equation of a circle, right? So you should be clear with this part. So vector representation for a circle, right? In the next graph, I'll consider the theta to be on the other side. Okay, so here it is something on the clockwise direction. For example, in the above situation, I consider theta to be on the counterclockwise direction. Okay, so that's the general convention. Therefore, I took theta to be on the anti-clockwise direction. Fine. So that's not necessarily to be the case in every situation. Okay, so it could be other way around also, right? So in that situation, how will I get the vector r? That's what I'm supposed to find here. Fine. So in this situation, the x was closer to the theta. Okay, so I got cosine to it, right? So here x was cosine theta was equal to x divided by r, fine. So every time, so the adjacent side will get the cosine component, right? Because cosine theta is nothing but the adjacent divided by hypotenuse, fine. So in this situation, the axis that is closer to the theta is like y axis, therefore y should be my cosine component, right? Because this is my theta, therefore this will be my adjacent side, therefore cosine theta will be equal to adjacent divided by hypotenuse, which is nothing but y divided by r, fine. So for here in this situation, for the second case where I took the theta to be other way around, which means like clockwise direction, in this situation here vector r will be equal to r sine theta I cap, because along the x-axis that seems to be like the opposite side, right? Therefore or sine theta I cap. So instead of cosine theta with respect to I cap, I got sine theta I cap because I took the theta on the other side of the line, okay, on the other side of the vector, okay. So here you got like r sine theta I cap, and same way you'll have r cosine theta j cap, right? So you should be clear with the thetas that I'm about to choose, right? So the component that is close to the theta will always have the cosine component into it. So same way the theta, that is the side that is opposite to the theta, will have sine component into it, right? So here you got r sine theta I cap and then the r cosine theta j cap. So you should be clear with the direction of rotation. Same way you should be clear with the theta that I'm about to choose, right? Fine. So, so these are the things that you need to know regarding trigonometric functions, sine, cosine and tangent theta. Next, what we will see is what are all the values that you need to memorize for that particular sine, cosine and then the tangent theta, okay. So there are some set of values that you need to know. You might have known in the lower grades itself anyway. There are some values that you need to memorize, okay. So that's going to be like for 0 degree, 30 degree, 45 degree, 60 degree and then the 90 degree, okay. Respective radian will be like 0, pi by 6, pi by 4, pi by 3 and pi by 2 are the respective radians, okay, for those degrees, okay. And the theta that I need to get is like for sine theta, cosine theta and tangent theta, right? So you should be clear with the convention of degree and then the radian. Radian is something that has mathematical background to it, whereas degree is something that is easy for us to understand and perceive, okay. Therefore I use degree generally, but to get mathematical background to it or to use it into a formula, you should be clear with the radian stuff, okay. Got it? So sine 0 degree, so sine 0 degree will be like 0, okay. So sine 0 degree will be 0 because how will I get the sine theta? Sine theta will come something like this, opposite divided by hypotenuse, right? So sine for 0 degree, you will not have any theta into it. Therefore, you will not have any opposite side. Even though the hypotenuse is just matched with the adjacent, but still you will not have any opposite side into it. Therefore, sine 0 degree will be like 0 0, okay. 0 divided by hypotenuse, that is obviously going to be like 0, okay. So as the angle starts sweeping, you'll have like you'll start having opposite side, which is going to increase. Therefore for sine 0 degree, it starts from 0 and then it increases till it reaches maximum, which will be like 90 degree, okay. So in 90 degree, you get the opposite side to be the hypotenuse, right? So opposite and hypotenuse will match each other, so that's going to be the maximum value, which will be like 1, okay. So sine 0 degree will be like 0 and the maximum value will be like 1. So in between, so you'll get the values in between, right? From 0 to 1, that will be for 30 degree, 45 degree and 60 degree, okay? So for 30 degree, you'll get like 1 by 2, okay? Then for 45 degree, you will have like 1 by root 2, and then for 60 degree, you'll get like root 3 by 2, then comes 1, okay. So that is how sine theta increases, which means it starts from 0 and then it goes to 1 by 2 and then 1 by root 2, root 3 by 2, okay. So to keep it in mind easily, what you do is you just take like 1 quarter, 1 by 4 and then take root of it, you'll get like 1 by 2. Then you take half and then take root of it, you'll have like 1 by root 2. Then you take like 3 quarters, which is like 3 by 4 and then you take root to it, you'll get like root 3 by 2, right? So if you just remember in that fashion, you will never confuse this one, okay. It will always propagate in like quarter, half and then 3 quarters, okay. And then take root to it, you'll get sine theta for it, fine. So there isn't any relation between this and then the theta that you're getting here and then the answer that you're getting here. The thing is, so you just did the experiment and then you calculated like opposite divided by hypotenuse and all those things, and you ended up getting 1 by 2, 1 by root 2, root 3 by 2. In order to remember this one easily, I gave you this trick, which means like take root of half I mean like quarter, half and 3/4, you'll get the answer for 30 degree, 45 degree and 60 degree. Okay. So now I have got the sine theta, then I'll have to get the cosine theta, right? So for cosine theta, how should it be? It should be like adjacent divided by hypotenuse. In the first case, when cosine 0 degree, adjacent and hypotenuse was same, right? So in that situation, it will be like 1 divided by 1. Therefore, it starts from 1, and then as the angle sweeps hypotenuse, you will start generating hypotenuse. Same way, adjacent will keep on shrinking, and then when it reaches 90 degree, adjacent goes to 0, and then you will only have hypotenuse. Okay, so in that situation it will be like 0 divided by 1. So it starts from maximum and then goes to 0 for hypotenuse for cosine theta. Okay, therefore it starts from maximum, which is like 1, and then it ends in 0. Okay, so it is like an other way around for the sine theta. Therefore everything will get flipped. So it will be like for cosine 0 degree it's like 1, and then you'll have root 3 by 2 for 30 degree, then you'll have 1 by root 2. So it seems to be like a mean position, so that will be the same thing, and then you'll have like half, and then it goes to 0, right? So for getting sine theta, you just have to put 0, 1 by 2, 1 by root 2, root 3 by 2, 1. So in order to get the cosine theta, just flip it. Okay, 1 root 3 by 2, 1 by root 2, 1 by 2, and then 0. Okay, just flip it, you'll get the value for cosine theta, right? So to get the tangent theta, it is simple. Tangent theta is nothing but sine theta divided by cosine theta, right? So sine by cosine will get you the tangent theta, which is nothing but 0. If I just cancel it out, I have like 1 by root 3. So that this will be like 1, and then this is going to be like root 3. 1 divided by 0 goes to infinity. Okay. So this is the value for tangent theta, right? So you should be clear with this sine theta, cosine theta and tangent theta. These are the numbers that you need to memorize, fine. So this number actually comes up again and again in the upcoming chapter. Therefore, you should memorize this one, okay? It is mandatory that you need to memorize these things, fine. So it should be clear. Then we will see how to get the values for other thetas. For example, sine 120 degree, sine 135 degree. How should I get the answer for those things? We'll see that one using the graphical thing. Okay, so we'll see that in the next page. Here I have plotted the graph for sine and then the cosine theta. Okay, so the first one is like sine theta and the second one is like the cosine theta. I have plotted it, right? So if you remember this graph in your mind, then it will be easy for you to get the answer for sine 300 degree and 135 degree. It becomes super easy. Okay, so you'll have to remember this graph. Okay, so even this graph comes again and again in the upcoming chapters, you'll get used to it, right? So for sine theta, it will look something like this. It starts from 0 and then it goes to maximum value, which means like 1. Okay, and then what it does, it goes to the second quadrant. Okay, so it starts from the first quadrant, sine theta opposite by hypotenuse. That's how it moves. Then it moves to the second quadrant. Okay, so when it comes to the second quadrant, what happens? The opposite side starts decreasing. Okay, so it goes to the maximum value and then it starts decreasing. Fine. At 180 degree, it just completed half of the circle. Then what happens to it? This y becomes negative, right? That will be my opposite side in that situation. So in the first and second quadrant, the answer was like positive because that opposite side was on the positive y-axis. But in the third and fourth quadrant, the y-axis is negative. Therefore, I got the value to be negative. Okay. So that is how we plotted this graph. Fine. So you should be clear with that logic. The thing is, so with the imagination of this graph itself, we'll be able to find the value straight away. Okay. So now what I need to do is I'm going to get the value of sine 300 degree and sine 135 degree, right? So once you are familiar with the sine graph, then cosine graph becomes super easy. Okay. So it is straight away related to this sine graph itself. Fine. So here it starts from 0 and then it ends with 1 for 90 degree. Then what happens is it goes to the second quadrant where it just peaks to 1 and then it started decreasing. Okay, so you'll have like 1 to 0 up to 180 degree, then it got flipped, which means 0 to -1 and then -1 to 0. Okay, so here the interval how it actually increases is, first it increased from 0 to 30, an interval of 30. Okay, then it increased an interval of 15. From 30 it moved to 45, then another one 15, which is like 60 degree, then came the 90 degree. Okay, so 30, first interval was like 30, then the next two interval were like 15 and 15, the final interval was like 30 degree. Okay, altogether you got like 90 degree. So that's how it actually moved. Fine. So that's for like 0 to 90 degree. So the other interval should also be the same thing, right? So the next interval should be like 30, which means 90 plus 30, which is going to be like 120. And then you'll have like 15, which will be like 135. And then you'll have like another 115, which will be like 150. Okay. And then you'll have like one more 30 to it, which will give me like 180 degree. Okay. So that is how this graph will look like. Then after 180 degree, again, it will start flipping. Okay. So it just moved from 0, 1 by 2, 1 by root 2, 1. 1 by root 2, root 3 by 2, and then 1. Then what happened is it just started decreasing. 1, root 3 by 2, 1 by root 2, 1 by 2, 0. Okay. Then what happened is after 180 degree to 360 degree, it just started moving in negative direction. Same value, but the thing is it is in negative direction. So it will be like 0, minus 1 by 2, minus 1 by root 2, minus root 3 by 2, and then negative 1. Okay. So this is how we'll have to remember this graph. If you have a pictorial understanding of this graph in your brain, then it becomes easy for us to get sine 30 degree, 300 degree, and then sine 135 degree. Okay. So you should be clear till 90 degree. Then just by logical understanding, you'll be able to get 300 degree and 135 degrees straight away. Okay. So this is like sine. Let me first do it for like sine 135 degree. So that will be easy. Okay. So the closest value to sine 135 degree was 90 degree, right? So how much should I add to 90 degree to get 135? I know obviously sine 90 degree was equal to 1. Okay. How much should I add to it? If I add like 30, it will be like 120. To get 135, it should be like 45, which means like 2 interval has passed. Okay. So from 1, the first decrement would be like root 3 by 2. Then I'll get like 1 by root 2, right? So for sine 135 degree, the answer is simple straight away, which is like 1 by root 2. Okay. This is how you need to remember. It becomes easy, right? So then for sine 300 degree, okay. So 300 degree, what is the closest value that you should know? You should know the thing like 270 degree, right? So the thing that you need to remember is like 0, 180, and then 270, 360, 90. Okay. From that, I'll just try to find the offset distance. Okay. So here the closest thing to this 300 degree is like 270 degree. I know for 270 degree, it will be like negative 1. Okay. Because 180 degree is 0, and then negative 1 will be like 270 degree. Fine. From negative 1, leave the sign. Okay. Although sign is going to be like negative. Okay. From negative 1, it will start decreasing. Okay. So from 1, it will move to root 3 by 2, right? So from 1, it will move to root 3 by 2. But in this situation, it was like negative 1. Therefore, from negative 1, it will move to negative root 3 by 2. So for sine 300 degree, you'll get the answer to be like negative root 3 by 2. Okay. So now I have got the sine values. Then what I will do is I'll get the cosine values to it. Okay. So to get the cosine graph, it is simple. Just move this y-axis by offset distance of 90 degree. Okay. Then you will get the cosine graph. That's it. Finished. So this is my cosine graph. Just offset distance of 90 degree will give you the cosine graph. Fine. So here you got the maximum value to be like 1. It starts from 1 and then it ends in 0. That's how the interval is between 0 to 90 degree, right? Then it goes to the negative side. Fine, because you consider the x-axis. Therefore, in the first quadrant, x was positive. In the second quadrant, the x was negative. Therefore, in the second quadrant itself, the cosine becomes negative, and then it is still in the negative, then it becomes positive. Okay. With the graphical understanding, it becomes clear how we have plotted this graph, but in every situation, you will not be able to imagine those graphical thing. Okay. This graphic, that graph, but this curve is easy for us to imagine, right? Therefore, here it started from 1 and then ended in 0 for 90 degree. Then 90 to 180 degree, it became like negative 1. Then for 180 to 270, it becomes 0. Then from 270 to 360, it became like 1. So these are something that you need to know. From that, I'll be able to get the value for cosine 300 degree and then the cosine 135 degree. So let me put it into perspective. Here you got cosine 300 degree. So what will be the closest thing that you need to remember? It's like cosine 270 degree, right? So cosine 270 degree is obviously 0, right? Okay. From the graph, it is pretty clear. Or you just remember it. 90 is like 0 minus 1 and then again it comes to 0. Okay. So you get 270 degree to be like 0. And then what should be like 300? How much should I add? It's like 30, right? So that will be my first interval. Okay. So for the first interval, it started increasing. So from 0, how should it actually increase? From 0 to 1 by 2. So that's how it's going to increase. Therefore, for cosine 300 degree, the answer will be like 1 by 2, right? So now I have got for cosine 300 degree, which is nothing but 1 by 2, right? Next, I will find it for cosine 135 degree, okay? So to get the cosine 135 degree, the starting point that I need to choose is 90 degree, okay? So if I add like 45 to that 90, I'll get like 135, right? Same thing, okay? So 2 interval has passed, right? So cosine 90 degree will be equal to 1 and then it becomes negative, right? So 2 interval has to pass. So if 2 interval passes, then you'll have 1 by root 2, right? But this will be negative, therefore you'll get negative 1 divided by root 2. That will be my answer, fine. So now you should be clear with cosine theta and then the sine theta, okay? So whatever thetas that they give you, you should be able to find cosine and then the sine function, fine. So just remember the values between 0 to 90 degree and the graph, okay? If it was like sine function, it starts from 0. If it was like cosine function, it starts from maximum, which means like 1, okay? So if you just remember that convention itself, you'll be able to get cosine and sine function straight away, right? So for the interval between 0 to 360, it is easy for us to find the values of cosine and then the sine function, okay? Same way, if they give you theta that is greater than 360 degree, again the same cycle is going to repeat, okay? If it was like greater than 360, then remove the 360 from it, then use the rest of the values to get the thetas out of it, right? So because the same pattern will repeat again and again, right? So you should be clear with this cosine and then the sine function and the tangent function that we have seen, okay? So these are the trigonometric functions that you need to know, right? So now we are into the last part of this session, which is like parallelogram law. Here you got two vectors which are like vector A and then the vector B, okay? And the angle between them is theta, fine. So here what I need to find is the resultant vector formed by the addition of these two vectors. That's what I need to find here, okay? Graphically it is easy because I just have to put the tail of one vector on the head of the other. I'll end up getting the resultant vector. But the thing is, if they give you in numbers and then they give you the theta between them, then what should be the magnitude of resultant vector? That's what I need to find, okay? So here if the theta was equal to 90 degree, then it is easy. Straight away I'll be able to use Pythagoras theorem and then I'll get the magnitude of resultant vector, okay? But here in this situation, the theta is not necessarily 90 degree, it could be some other angle. It could be 90 degree, but it could also be some other angle, okay? If that was the case, then what should be the magnitude of resultant vector? That's what I need to find, okay? So it is pretty clear. This thing looks like a parallelogram. Therefore, this is called as parallelogram law, okay? The same thing in the first part of this session, we did do the vector addition and the final thing looked like a parallelogram, okay? So same here, the same logic that we are about to use here also, but the thing is, I'm just going to find the resultant vector using only the magnitudes of vector A and then the vector B, okay? Right, let me do it. So if I do the vector addition, I'll get the resultant vector, fine. The thing is, I need to get the magnitude of it, right? To get the magnitude of it, I wouldn't be able to use right angle thing because this is not 90 degree, right? So now what I'm about to do is I'm just going to get a bigger right angle triangle just by splitting this vector B into two components, which means one component will be like horizontal and the other component will be like vertical, right? To get this stuff, I need to match the theta, right? So that is when I'll be able to get this one, right? So to match these two things, this line and this line are just the same parallel line, right? So I just moved it by offset of certain distance to get this one, but these two lines are parallel, okay? So in that situation, how will the theta gets related? So that's what I'm going to see, right? So these are something that you might have learned in your lower grades itself, okay? Corresponding angles and alternate angles and then the opposite angles, okay? We'll see that one once again here. So these two are parallel lines. Same way, it is cut by a common line, okay? So there is a common line that cuts two parallel lines. So in that situation, how will the theta be related? That's what we are going to see here. So here 1 and 2 and 3 and 4 are opposite angles, right? Obviously. So we have 1, 2 and 3, 4 are opposite angles. Got it? So 1 is equal to 2, same way 3 is also equal to 4, okay? We know that these two lines are actually parallel, which means this common line is going to symmetrically cut these two lines. Then obviously 1 and 3 and 2 and 4 should also be same. Therefore, these two angles 1 and 3 and 2 and 4 is same and I'll call it as like corresponding angles, okay? Something that is with the same cut will be like opposite angles. Same way, if it is going to cut symmetrical way with other parallel line, then those two angles are considered as corresponding angles, okay? So here 1 and 3, 2 and 4 are also same, and that too it is like corresponding angles. Okay, so here angle 1 and 3, same way angle 2 and 4 are equal, and it is called as corresponding angles. Okay, got it? You might have learned this one. Okay, so next what combination is there is something like this, 2 and 3, right? So 2 and 3 is actually an alternate angles, fine. So alternate angle generally comes within that Z shaped thing. Okay, so if you are able to get an Z shaped thing, in that situation the angle inside that Z will be like alternate angles, fine. So here 2 and 3 are actually alternate angles. Okay, in this situation all those angles are just the same thing, 1 2 3 4 all are same, just I'm getting you the perspective here. So if it is in the same cut, then I'll call it as opposite angles. If it is symmetrically cut with another parallel line, then in that situation I'll call it as like corresponding angles. If it is inside that Z shaped thing, then you'll call that angle as alternate angles. Okay, so here alternate angle is like 2 3 or alternate angles. Okay, fine. So here in triangle, so here in this situation, I'm just going to get a bigger triangle. In that triangle, I'll name it as like triangle PQR. In that triangle, I'll be using this corresponding angles to get the same theta into this splitting. Okay, so here I'll split this vector B into two component, which will be like one horizontal component and the other one will be like this vertical component. Okay, so this angle will be like 90° as usual. This is a right angle triangle. If I need to split this B, I'll have to get a theta matched with this theta, right? So here these two are nothing but the parallel line. Okay, same way here these two are like a parallel line, fine. So this theta and this theta should match because these two are like the corresponding angles, something like this, 1 and 3 that situation, or 2 and 4 that case, right? So as these two are parallel lines, it is cut by a common line. So if this angle was like theta, then obviously this angle should also be theta. Okay, so let me put theta here. Then what should be the component that is closer to theta? It should be like cosine theta, right? So that will be b cosine theta, and this component will be like b sine theta. Okay, now I have splitted it. I've split it such that you got like b cosine theta and then the b sine theta. Next what I will do is I'll just consider this complete larger circle to be my right angle triangle, and this triangle is actually PQ and R. Okay, so this triangle is triangle PQR. Okay, so in this bigger triangle PQR, I'll be able to substitute Pythagoras theorem. Let me substitute Pythagoras theorem and I'll try to get a common answer out of it. Okay, so in the first case, triangle, in the first situation where you got like triangle PQR, if I substitute Pythagoras theorem, you will have r square, which is equal to side square plus side square. So the first side will be like a plus b cosine theta the whole square plus, right, a plus b the cosine theta whole square plus b sine theta the whole square, right? Got it? Now let me expand it, right? So if I expand it, let us see what will I end up getting. So a plus b cosine theta the whole square, right? So that is like a plus b the whole square. So you'll have a square plus b square, I mean, yeah, right, b square cosine square theta plus 2ab cosine theta, right, plus 2ab cosine theta plus b square sine square theta. So this is what you'll end up getting. So here what I do is I just consider this cosine square and then sine square theta together. So you'll have like b square cosine square theta and then b square sine square theta, right? If I just factor out b square from it, you'll just have cosine square theta plus sine square theta. We know that cosine square theta plus sine square theta will be equal to 1, right? So this is just a trigonometric relation that you need to know, fine. You might have known it from your 10th grade itself, right? So this is like cosine square and sine square theta. Those two things will get cancelled out. Then I'll just be left with a square plus b square plus 2ab cosine theta, right? So the vector r that you are about to get here will be like a square root of, so the r that you will end up getting will be like r, which is equal to root of a square plus b square plus 2ab cosine theta. So that will be the magnitude of resultant vector. Fine. So here, if they given you angle other than 90 degree to get the resultant vector, the the formula that you need to know is root of a square, where a is the magnitude of vector a plus b square plus 2ab and then the cosine theta. That gives me the angle between those two thetas, right? We have already known if theta was equal to 90 degree, you should end up getting r, which is equal to root of a square plus b square, right? So let me use that formula, the 2ab cosine theta formula, and then I'll substitute theta to be like 90 degree. Then let me check whether I get that Pythagoras theorem, that formula itself straight away, right? Okay, you'll end up getting that one itself. So here I've just considered a case where you got like a to be like magnitude 3 and then the magnitude of b was like equal to 4. If I substitute that formula, then you'll have like a square, which is nothing but 3 square plus b square, which is like 4 square, and then 2ab cosine theta, right? Cosine 90 degree is obviously 0, right? Therefore, the third term will go to 0. Then you will end up having r, which is equal to root of 16 plus 9. That's going to be like root 25. Again, you'll get the answer to be the same 5, okay? So, for 90 degree, that was a kind of special case, okay? But if it was angle other than 90 degree, then use this formula r, which is equal to root of a square plus b square plus 2ab cosine theta, okay? The topics that we discussed in this class were vectors, okay? You should be clear with the basics of vectors that we have seen. And then we saw trigonometric functions. You should be clear with sine, cosine and tangent theta. I asked you to memorize certain thetas and its numbers, okay? You should memorize that one also, fine. We did see what is meant by unit vectors. You should know that one. Finally, we saw parallelogram law, okay? Using this parallelogram law, we will be able to find the resultant vectors of any two vectors, okay? And it doesn't matter whatever angle they give you, you should be able to find using parallelogram law, right? So that is what we have seen as the last part of this session, okay? You should be clear with all those topics that we have discussed, fine. With this, the video gets completed. Bye.